Hello, everyone. How are you guys doing today? Good. It's so nice to see you guys again. And please don't use your phone anymore until the class is over or the laptop. I mean, if you're using it for the recitation, it's fine. But otherwise, no phone, no computer, no laptop. Okay? Concentrate on me for 15 minutes only. And then you can leave, do whatever you want to do. So, they have strict policy when the due date is over, they actually make it unavailable. So you guys didn't see the previous recitation upload because the due date was 2/28. However, I just opened them up for 2 more days. So if you haven't uploaded 1, 2, 3, 4 recitation yet, please upload them there. It's under the recitation worksheet upload on Lumen. And again, you can upload only one file. So you have to convert your pictures into PDF, one PDF, and then upload there. And to access all those recitation, you go to the yellow tab bar where it says recitation worksheets, and all the worksheets are there. Okay. So download them from there. If you have computer to write on or tablet, you can do them online. I mean, you can do them on your tablet and then convert into PDF, upload. But if you don't have anything, print the worksheet, do them by hand, and then take pictures, convert into PDF, and then upload. You have your choices. Okay. However, if you print out before class and you're done in class, you can hand them in class. Any question?
I have uploaded the recitation with two, but for some reason it doesn't show that it was uploaded in my system.
What is your name?
Renata,
okay, I'll check from my side.
I know.
And if I see the upload, I'll email you.
Yeah, I sent you a message even with the work done. Uploaded to you.
Okay, no problem. Okay, so one announcement. So tomorrow we're supposed to have a Wednesday schedule. Okay, but we're not going to meet because tomorrow we are going to the same recitation. Today is supposed to do page 1, tomorrow is supposed to do page 2. Instead of doing same recitation twice in 2 days, we can do everything in one day. Okay, so you can complete the recitation today, and you don't have to come tomorrow. So you're not going to have any recitation tomorrow. And today's recitation is actually kind of fun. It's a small recitation, only 2 main questions. The main idea here is solve inequalities. So we know how to solve equations. Similarly, we solve inequality. The difference between solving equation and solving inequality is that when you solve an equation, you get one solution or two solutions, okay? Or a limited number of solutions. But when you solve inequality, we get a set of solutions. So our answer is an interval, not one number or two number, it's an interval. So main idea behind today's recitation is to find out which intervals satisfy the given condition, whatever condition they give us in the equation. Question before we start. Did you guys go over that in class, in the lecture?
We don't have this one yet.
Not yet? Cool. So I'm introducing you to the topic. I'll try to make it as easier as possible. So if you have any question, anytime you don't understand anything, raise your hand, ask me a question. In the first page, we are solving inequality that has no denominator. So it's easier. So let's see, we have A is a quadratic, B is also quadratic, C is also quadratic, and D is kind of different. Let me do C first, because it's easier, it's quadratic. You all know quadratic equation, right? So based on the equation C, negative x squared minus 8x minus 15, what type of parabola we have? Upward or upside down? Upside down. That's because we have the negative in the front. No. Now they're saying in this upside down parabola, which portion of the parabola is lying below the x-axis? Less than 0 means below x-axis. So it's the negative portion. And this is same as it's below the x-axis. So we know we have an upside down parabola, and our goal is to figure out which portion is lying below the x-axis where our y values are negative. So you have two ways of doing it. Either you draw your parabola and then figure out, or you can draw a number line and then you pick a number from each interval and see which interval gives us negative y value. It's up to you. But it doesn't matter which method you follow. The first step is always, what is your x-intercept? It doesn't matter whether you use the number line or whether you use the graph parabola. You need your x-intercept, the boundary. So step 1, find your x-intercept. What do you think I should do first? Factor out what? We can do that, and we can also take out. Why is shaking? It is shaking for some reason. We can pull out negative as a common factor, and then our parabola will become a positive one. So it will be easier to factor. So let me slow it down. So if you pull out a negative, we get x squared plus 8x plus 15 less than or equal to 0. And now we can easily factor that. Can you think of two numbers multiplied to 15 combined to 8?
3 and 5.
3 and 5. How about their signs? Positive. And then from there, we solve for x to get our x-intercept at the boundary. So this gives us x equals -5, -3. So we have an upside down parabola where we have x-intercept -5 and -3. Let's draw the parabola. -5 and -3. Okay. So it's both on this side. 1, 2, 3, 4, 5. So this is one x-intercept. This is another x-intercept. And we don't care about the vertex because our goal is not about the vertex, but which portion is lying above and below the x-axis. So this is -5 and this is -3. Any questions so far? No? Now, based on the graph, which portion is lying below the x-axis? Definitely the two-end tail, right? So this is below x-axis, this is below x-axis. Now, finding solution means what is the x interval for that portion? Yes. So in this portion, we have the smallest x value -infinity, and we have the highest x value -5, right? That left tail has the smallest x value -infinity to the largest is -5. And -5 is included because we are looking at all those numbers where y is either 0 or y is negative. This is what they're telling us. When this function is lying on the x-axis, it's lying below the x-axis. So when x is -5, it's lying on the x-axis, so it's a bracket, and all this portion, the x values are from the smallest -infinity to the largest -5. But we still have one more part, right? The right side. So who can tell me the interval for the right side? -3 to positive infinity. And we have to include the -3 because -3 is lying exactly on the x-axis. So this is our solution. Go ahead.
Why is it that we're excluding what's in between -5 and -2?
Between -5 and -2, the portion of the graph. Is it like above the x-axis or below? So above the x-axis means your y values are positive. Below the x-axis means your y values are negative. And the question is saying, tell us the portion of the graph that is below the x-axis, where your y is negative. Less than 0 means negative.
If can I multiply the whole equation by -1 and then change the sign instead of minus in
You'll get the same result anyway. Because when you multiply or divide by negative, the inequality less than will become bigger than.
Yeah, this one's like, but then we change bigger than, and then we come to the same result.
Same result. Alright. So when you become bigger than, it becomes upward, right?
Yeah.
So which portion is bigger than y, bigger than x-axis? On the left side and on the right side, which is exactly the same thing. So for quadratic equation, you can actually simply graph and then see your results. However, the last one is not quadratic. And most likely we don't know the graph. So when you don't know the graph, we do a different method. We pick y value, x value for each, between each x-intercept, and then we see what's the y value we have there. So step 1, we distribute and bring everything to one side so that you can see what you're looking for. Are you looking for something positive or something negative? We want to see that. For example, on C, we could see it, so we simply went and factored. But here, we don't see it. So we want to see 0 in one side. That's a condition. See 0 in one side. So when we distribute, we get 5x cubed minus 5x on the right side. And the left side stays same. Now we have to bring everything to the left side. So you subtract negative 5x cubed and add the 5x. So left side becomes x to the 4 minus 5x cubed minus x squared plus 5x. And now we know what you're looking for. What are you looking for? Something positive or something negative? Positive, bigger than 0. And it's only positive, strictly positive. Y has to be positive. It cannot be 0. It has to be strictly positive. So what do we do when we have forms? Our goal is to see our x-intercept. That's the main idea.
Do you factor out its power? So if it's
Least power,
so if it's negative x2 factor it
we
out,
can pull out x because they all have
x.
x. They all have x, right? So you can pull out an x. And we get what? X cubed, and then minus 5x squared minus x plus 5. But we still have 4 terms. We still don't know what is our x-intercept. So it is our next step. Do you remember how do you factor 1 in 4 terms? Go ahead. Grouping. Since we have 4, they're even, so we can group them into 2 groups and factor individual group. So in the first group, do you see something in common? X squared. So you pull out the x squared and we get, what is left in the first group? X minus 5. And now what do you see common in the second group?
-1.
-1. They have nothing in common. When you have nothing in common, you always have 1 in common. And our second group started with a negative sign. We never want to start anything with negativity. For example, our daily life, we want to start our morning with something positive, right? If our morning becomes negative, bad, our whole day becomes bad. So you always want to start anything positive. But our second group started with a negative. So we want to pull out a negative as a common factor. So the second group becomes positive. So we pull out a -1. And we get x minus 5. It's x minus 5 because pulling out means you are dividing. So we have +5, you are dividing by -1, that gives us -5. Anytime we factor out any negative, the remaining, everything becomes, they change their sign. So -x turns into +x, +5 turns into -5. And if you observe, we still have our two groups. Do you see same thing in both groups? X minus 5. So this time we factor out x minus 5. And in the first group, we have x squared. In the second group, we have -1 left. And don't forget about our GCF. We still have our GCF. Are we done factoring? No. No. What else we can do? X squared minus 1. We still have more to factor. So what two factors we get from there? X plus 1, x minus 1. And we still have from before x and x minus 5. Ooh, there are so many x-intercepts we have here. Since we don't know the graph, so what we do, we place all these x-intercepts into the number line. So let me do it here. The first one is x, this gives us 0. The second one is x minus 5. So this gives us x equals 5. Then we have x plus 1. This gives us x equals -1. And lastly, we have x minus 1. This gives us x equals +1. So we place them on the number line from between negative and positive infinity. So 1, 2, 3, 4. Which number goes on the left? -1, the smallest one. The next number is 0. Don't forget about your 0. And then, and lastly, 5. So we know these are our 4 x-intercepts. And our goal is to see on which interval, between which two numbers, our y values are positive. Because they are looking for something bigger than 0, positive. So what we do, we pick point from each interval and see what's the result for that interval. So let me write down the question here again. So it will be easier to substitute. We have x times x minus 5, x plus 1, x minus 1. So this is the y. And then we pick something from the first interval. Pick any x value from the first interval. Anything that is smaller than -1. -2. We have to substitute for every x into our equation to see what's the y we have. So when y is -2, our x is negative. When y is -2, our second term is also negative. Right? So -2 is negative. -2 minus 5 is negative. -2 plus 1. What is -2 plus 1? Still negative. What is -2 minus 1? Still negative. So we actually don't care about the number because we only look for the sign. So every term in this first interval is negative. So when you multiply all these intervals, all these signs, what do you get? Positive. So this will be inside our solution. In this interval, we have our y positive. So let's highlight. Then we go to the next interval and see what happens there. We pick any number between -1 and 0. -0.5. So it's -0.5. I miss my negative again. -0.5. So -0.5 gives us negative results. -0.5 minus 5. What do you get? Positive or negative? Negative. So the first one is negative, second one is negative. -0.5 plus 1. Positive because 1 is bigger. -0.5 minus 1. Negative. So this time we had 3 negatives. The result is, when you multiply them, negative. Are we looking for negative or positive? Which one? So this will not be inside our solution. We just wasted our time. Then we go to the next interval again. Anything between 0 and 1.5. And we do the same thing. When x is 0.5, it's positive. The next is 0.5 minus 5. Negative. The next one is 0.5 plus 1. Positive. And lastly, 0.5 minus 1. Negative. So when you multiply plus, minus, what do you get? Positive. And you're looking for positive, right? So this will be inside our solution. So you already found 2 solutions, 2 sets of the solution. Then we go to the next one. We have to keep doing that until we cover everything, all those interval.
In this one, for example, I think we have a graph. Can I do the graph? Because I think it's faster.
If you know your graph, definitely use the graph. Graph is much easier.
Yeah, it's much easier because when you have too many rules, right?
So if you know your graph, life is easy. But how many of you know how to draw this graph? See? I don't know. Actually, the graph is much easier. You have to remember what I taught you last time. Positive coefficient even degree, negative coefficient even degree. If you follow your 4 polynomial rules, it is easy. Okay, the last, no, not the last thing. The second last thing. Anything between 1 and 5. 3. So in the next interval, we have x equals 3, and we substitute all those x. So when x is 3, it's positive. Then we have 3 minus 5. 3 minus 5 is negative. And then we have 3 plus 1, positive. And lastly, we have 3 minus 1, positive. Oh, we have only 1 negative. So our result is negative. But we are not looking for negative, so we cannot take the third interval in our solution. So fourth interval. And now the last one. any number bigger than 5. 6. So what do you have? 6 is positive. 6 minus 5, positive. 6 plus 1, 6 minus 1, all of them are positive. So the result is positive. So this will be inside our solution. So when you write the solution, all you have to do is write the 3 intervals that satisfy the positive condition in the in interval notation. So your solution. How do you write the first interval? Negative infinity to negative 1. And are you going to use bracket or parentheses? Parentheses, because we cannot have equal, they didn't give us equal sign in our inequality. So when you don't have equal sign, it's parentheses. Means we don't want to have y 0. When x is negative 1 or y is 0, we don't want that. Then what is our second solution set? From 0 to 1. And what is our last solution set? 5 to positive infinity. So you combine all of them in one interval notation, and that's the answer. Negative 1 to 0 gives us negative results. Okay. Oh, we don't want the negative result, we want positive results. Any other question? No? So these are polynomial. They don't have any denominator. The next page, what we're supposed to do tomorrow, we're going to do it today anyway. It's the exact same thing, but now it's rational. So we have a denominator. When we have a denominator, the only difference between not having a denominator and having a denominator is that when we have a denominator, we also have to consider the denominator in our number line. Today is what? 3, 5. So let me see which one looks harder. Oh, there are only 2 questions. Then let me do B. A is simpler than B. Any idea about B? How are you going to start? We want to see 0. Otherwise, how do you know what you're looking for? So we need to add 3 to both sides. So we have x minus 7, x plus 5, plus 3, bigger than or equal 0. And then you have a problem. You cannot combine them until we have the same denominator. So what do you do? Don't do that, because if you do that, then your denominator will cancel out. And if your denominator cancel out, then you'll forget to count that in your number line. So instead of canceling the denominator, let's work with the denominator. We want the same x plus 5 below 3. So you can put it there as long as you can put it on the numerator. So instead of getting rid of the denominator, work with the denominator, because you need the denominator on your number line. And now you're happy. We have the same denominator, x plus 5. So we can combine our numerator. We can distribute and we have x minus 7 plus 3x plus 15 bigger than or equal 0. And then you combine like terms. What like terms we have? 3x and x. So how many x we have? Plus 4x. And then we have 15 minus 7. 8 over the denominator. And we can do more, right? We can factor out the 4 from the top. So we have x plus 2, x plus 5, and everything is bigger than 0. We'll make it a little smaller and write it here. 4 times x plus 2, x plus 5, bigger than 0. So what you're looking for here, something positive or something negative? Positive. So we have two things here. We want either y to be 0, because this time they have the equal sign, and we want where our y is positive. So everywhere where y is either 0 or positive, we want that interval. And we do the exact same thing. We solve for x from the top and also from the bottom in both cases. So we go x plus 2 equals 0, x plus 5 equals 0. So what is our x? And negative 5. So these are the two boundaries we have for this rational. One is the x-intercept and one is the vertical asymptote. So we place them in the number line just the way we did the previous one. Between negative and positive infinity, we have negative 5 and negative 2. We do the same thing. Pick anything before negative 5. Negative 6. And we place it here. We can ignore the 4 because 4 is positive anyway. So we have negative 6 plus 2 on the top. What do we have? Negative 6 plus 2 is negative. And on the denominator, we have negative 6 plus 5. Negative. So when you divide negative by negative, the answer is positive. And what you're looking for? Positive. Oh, we should write x cannot be 5 because that will make the denominator 0. So we definitely don't want our x to be negative 5. We cannot have negative 5 as our solution because that will make everything undefined. That's the vertical asymptote. So our first interval works. It will be inside our solution. Then we go to the next interval. Any number between negative 5 and negative 2. Negative 3. So in the numerator, we have negative 3 plus 2. Negative. On the denominator, we have negative 3 plus 5. Positive. So their quotient is negative. Can you take negative? Then we go to the last interval. Anything that is bigger than negative 2. Or 0. 0 is the best number, right? We don't have to do any math. You can do 4, but I love 0. So in the numerator, we have 0 plus 2. 2, positive. On the denominator, we have 0 plus 5. 5, positive. And positive divided by positive is positive. Can you take this interval? Yes, because you're looking for positive. So what is our solution this time? negative infinity to negative 5, not included negative 5, because when you have x negative 5, everything becomes undefined. Negative 2 to positive infinity, and how about negative 2? It is included, because that makes the y 0. So 2 can be negative, it makes the numerator 0, which is good, no problem. But what makes the denominator 0? It cannot include that. No problem then. And that's all you have to do in this recitation. So that means you have to do 3 questions only. 1 from the rational and 2 from the quadratic. Let me know when you're done with this. I'm going to scroll up. You can do the other one. And behavior. Okay, so there's space. So this is telling us that our left portion is lying above the x-axis. And then we have a vertical asymptote. So this is negative 5. This is 0. This is x-axis. And we have what, one more? 1, 2, negative 2. So this is telling us that before negative 5, this is what is happening. The left is going up, or it looks weird. Maybe this way. Horizontal asymptote. Yeah, true. It has a horizontal asymptote at 1. Y equals 1. Sorry, y equals 4. So this is 4. It has a horizontal asymptote at y equals 4. And the graph, this is negative 5, okay? This one, negative 5. So let me use this. So the line is, the portion of the graph before negative 5 is going downward. And then it says between negative 5 and negative 2, the graph is lying below the x-axis. And we have x-intercept at negative 2. So this portion is lying below the x-axis, and you're crossing through the negative 2, and then this portion is lying above the x-axis. So most likely this is the graph, even it looks weird. This is the graph. But then we have a problem here, because this is telling us that we have a square power on the bottom. We don't. It does look weird. Let me graph it, okay? Just to see what is happening here. What do you have? -7 plus 5. When they say graph it, you can just draw the number line, it's fine. X minus 5, sorry, x minus 7, right, on the top? X minus 7 over x plus 5. And this thing is less than, bigger than 3. Oh, if I write inequality, it makes weird. Minus 3. Why the horizontal asymptote is -4? Did I make a mistake on my answer? X or -3, so it's +3. See? So before, that's why I said it looks weird. It doesn't make sense. It really doesn't make sense. So what is happening here is from -5 on the left side, everything is above. Why did I write below? Man, everything is above the x-axis. Since we have a horizontal asymptote here, So this portion has to be above your horizontal asymptote, and the right portion between -5 and 0, it's below the x-axis, and other portion is above the x-axis. So how did I know my graph was wrong? Because in order to have the same direction, you have to have even power for that particular asymptote. But look at here, this particular asymptote has 1 power, not 2. Something was wrong, that's why I know. Does that make sense? Okay, any other question? So you guys done copying? Then you're going to do this example for rational, and then these 2 example for quadratic. And I will be here to help you. Let me know how I need help. X squared minus 1, so this, and the quarter is lying in between -1 and 2. So why do you have both? What do you mean? Why do you have two such stuff?
Yeah, I just left.
What? These are complementary, right? So which one is not? This. Or this one? You got your result from -1 to 1. So your answer is -1 to 1, not that way. Thank you. That was it. No. It's 2 pages, so I just don't remember.
That's
Okay.